Hello and welcome back to the channel. Today we will travel some 30 years back in time, all the way to the beginning of 1990s. I have an old PC from my childhood in here. This is an Intel 80286 model. It has 2 megabytes of RAM and it used to have a hard drive of 40 megabytes, but unfortunately this device have died already. So maybe we can have another video where we look into it. But on this video we will have to rely on these floppy drives to load the operating system and to test some software. But what makes these old computers interesting even today for the hobbyists is that they run on fairly low frequencies. The clock frequency is, if I recall correctly, for this computer it's somewhere between 12 to 16 megabytes, megahertz. And if you compare that to the contemporary computers running on a gigahertz range, those are really hard for hobbyists to really access and work with in terms of using entry-level oscilloscopes and other devices, and they are really hard to solder anyhow. But in these old devices, for example, the CPU doesn't even have a heatsink, so that already tells something. But yeah, let's power it on. You get picture, yeah, it takes some time to warm the tube. And now it's booting from this floppy disk. Okay, now it's finally up and running. I have one floppy containing my very first basic programs. I prepared these when I was at elementary school. I was practicing programming on my own, and I made this I think on the 6th or 7th grade there. Let's see how it looks. Probably brings up many memories from the past. These programs are in Finnish. Yeah, it seems that it's from 1991. And let's see what's in here. There are all sorts of test programs that I prepared. Let's see what happens if we go to this sauna game. There's no screen buffering even. Okay, this game is about having a sauna. Let's see what happens if we pour some water to the sauna heater. And then we can have a beer. Okay, it doesn't encourage to have a beer. We can open the window for a while and it cools down a bit. Let's see what happens if we take the swimming suit. And what happens if we go without the swimming suit? Okay, let's see if we'll take a shower. The drain is broken and it accumulates water on the shower. You are supposed to stay there as long as you can, but without drowning. Yeah, I think we survived. And then if we go out and to the snow, then you fell down and you fall down and start moving like a snowball, and then you are supposed to stay on this track. If you press the arrow down, then it goes quicker. You're supposed to keep yourself between those borders. Now let's switch another disk. Let's see what's in here. I reckon this Supaplex suits quite nicely to this theme of electronics. In a sense, this game is really similar to Boulder Dash, which is quite famous. We can have a demo for now. I really like these PC speaker sounds. They bring good memories from the childhood. Actually, I used to have a Sound Blaster Pro on this computer, but that's now moved to another device. The other reason I selected this game for now is that my original idea was to show how to connect this computer with Texas Instrument. I think it was model 85 graphical calculator, but unfortunately I lost all those connectivity programs when this hard drive broke down, so that's harder now. I've lost the cable I prepared years ago, but that's simple to prepare, so that wouldn't be an issue. Okay, let's test what happens if you try to play yourself. You can use the keyboard and then you're supposed to collect those valuables. That's probably enough for the software side for now, and let's open the case and have a look inside. it's good to realize that I've taken some safety precautions. First of all, this whole setup, including the display and everything, is floating. I'm powering it through an isolation transformer, which is really important when you operate with some mains powered devices. Secondly, if we are using an oscilloscope, I will use those differential probes, so that we don't accidentally ground this through the oscilloscope. It seems that there's quite a bit of dust inside. So what do we have then? First of all, there's one loose cable that used to be the ground lead for the hard drive. The hard drive was over here. I suppose these are the power cords for it. And then we have the floppy drives. They have this integrated drive engineers connectivity, and that goes to this I/O board that is responsible for the drives, and it also provides the parallel and serial ports. We have a serial mouse connected there. What's nice with these old electronics is that first of all, many of the components are socketed, and then there are many through holes components in general. Those integrated circuits are probably the only surface mount components. We can see the processor over there, and as I said, it doesn't have a cooling at all. There's no heatsink or anything. Then we have the crystals. We have the 16 megahertz crystal, and then another one for the 24 megahertz. The CPU itself goes up to I think 25 megahertz. But these are the crystals of the motherboard at the moment. Then we have these extension boards using this industry standard architecture, ISA. This is the display driver, and again you have those socketed components there. I can't recall how much memory we had this on this display card. Not sure if this is the original one even, but on one of my old computers I used to have more memory on the graphics array than on the motherboard itself. And then here we have the modem, and it has its own speaker. What else? Of course we have the power supply, and then you can see that I've been doing my own adjustments and things in here. Most of those things have been removed already, but yeah. For example, there's a speaker that I used to replace the original one. These DACD chips are part of this motherboard chipset, and then on the right we can see the CPU on its own socket. Here on the left we have a couple of more crystals, and then we have those two identical EEPROMs, and I suppose that they are for this basic input-output system. I'm not sure about this rightmost chip, but below we can see more of those motherboard chipsets. These are the memory slots, and here they are from the other side. For the demonstration purposes, I've connected this differential probe to one of those IDE pins of the I/O card, and then we have this far from optimal connectivity for the other lead, but that's just to free my hands. So and we're doing this for demonstration purposes only. But now we can record that data stream on the oscilloscope. If we stop that and then we zoom in, we can clearly see what's happening there. And if you consider those contemporary computers, it would be much harder to do such experiments that you can actually monitor the running computer real time. Yeah, that was a quick introduction to this old computer. This is how they used to be 30 years ago. If you have some ideas, suggestions what to do next, what kind of things we could try with it, I'm happy to hear them. Please leave comments. I was planning to use the CRT for some experiments already, and I was also considering now these floppy drives. Maybe I should connect them to my laptop so that I could read many of the disks I was supposed to try with this computer, but now that the hard drive is missing, I don't have those decompressing tools in here, and also there's no space to decompress them anywhere, so that I could try them somewhere. So maybe I'll use an emulator on a laptop. But yeah, I hope you liked the video, and looking forward to see you on the next one. See you.